Okay, so if you end up with a rational function, now we kind of talked about dividing functions before in chapter 5, and pretty much all we were looking at is if I have a function where I have some type of polynomial, we're just going to use p for that function, so some type of function in the numerator and some type of function in the denominator. That would be a rational function, because it's a function that has a fraction within it. Now, if you remember back to chapter 5, when we were dividing functions, we had to then state what x could not equal, because we can't have 0 in the denominator. Okay, and we had simple linear functions in the denominator, so maybe we had something like this, where it said 2 over x plus 2, and then we would say x cannot equal what? -2, right? Because that would make me have a 0 in the denominator. So that was back to chapter 5, and they gave us nice, pretty linear problems like that. Now, in chapter 7, we're not going to have nice linear functions. We might have quadratic functions, which means then we would have to factor them to be able to find what values will become a 0. This is what we did at the end of that test. Okay, so the domain. If you're asked to find the domain of a rational function, so the domain of a rational function consists of all real numbers except those that make q of x, and we're just using q of x as a general rule of thumb, that make q of x equal to 0. Okay. So if you're asked to find the domain, your domain is going to be all real numbers, excluding whatever those values of x would make your denominator equal to 0. Okay? All right, so let's look at a simple function. Where are we at? That make q of x equal to 0.
Okay.
Got it? All right, so let's just look at some simple functions first. If I had function f, so f of x is equal to 2 over x minus 5, what would be the domain? I want to make sure I write this out the way this book is. So it's going to be all real numbers except what value of x? 5. So to find the domain, we set our denominator equal to 0. Then we solve for x, so adding 5 over gets us x is equal to 5. So when x equals 5, I get a 0 in my denominator, which is undefined, because remember, you can't have zeros in the denominator. So now we need to think about how we want to show our domain. We could do it in interval notation, which would mean we would go from -infinity to 5 with a parenthesis, then 5 to +infinity with the union sign in between. But that's a lot there. So what the book's having you do is they're putting it in set notation. So my domain is all values of x. So we're going to set notation. Remember that bar means the word such that x does not equal 5. And that would be your answer to the domain, right? Okay, a little bit easier than doing our union of intervals. Though if you did the union of intervals, I would not take off points for that. And when I mean that would be -infinity to 5 union 5 to infinity. So that would be everything excluding the 5, because we don't have the brackets there. So you take your pick. The book's going to have those for the answers in set notation. All right, on to the next. So now here we have the f of x is equal to 3 all over 7x minus 14. So see if you can do that one on your own. So my domain is the set of all x values such that x does not equal what number? 2. Good. X would be 14 divided by 7, which gets you to 2. All right. Step up our game a little bit. Oh boy, I see a quadratic trinomial in my denominator. I'm starting to get really excited, because I love factoring. All right, so now we have g of x is equal to 3 plus x all over x squared minus 4x plus 3. I'm asked to find the domain. So again, to find the domain, the only thing I care about is the denominator. Eventually we are going to care about what's in the numerator, but for now, with just domains, all I care about is that denominator. So I'm going to set that equal to 0. Lucky for you, the last section of chapter 6 had you solving quadratic equations using factoring. Lucky for you, this is a really easy factor. What are factors of 3 that get you to negative 4?
Negative 3 and negative 1.
Negative 3, negative 1. Your leading coefficient is 1. So what do my factors look like?
X minus 3, x minus 1.
Good. X minus 3 times x minus 1 is equal to 0. So what are my values of x? 1 and 3, or 3 and 1. I'll put it in 1 and 3 order when I put my answer. So my domain is the set of all x values such that x cannot equal 1, 3. So when you're in set notation, you can just throw that comma in there to put it in a list of numbers. Okay? We're okay with that? All right, what about this one? H of x is equal to 8x plus 2 all over 3.
Isn't it already?
Yeah, why?
Because there's no x on the top.
Right, so there's no x in my denominator. I just have a constant monomial. So there is no value of x that I can put into this function that will make my function become undefined. So this is all real numbers. Do you remember how to do all real numbers in interval notation? My domain would be negative infinity to positive infinity. Okay. And the last one for domain, here we do have an x in my denominator. So f of x is equal to 2 divided by x squared plus 4. If I set that equal to 0, can I factor that? Is that a difference of squares? No, it's a sum of squares. Now think about this. Is there any way for me to put a number in for x that would eliminate that positive 4? Like if this squared wasn't here, my x would need to be negative 4, right? So is there any way to square a number and have it result in a negative 4? No. It's always just going to be a positive number whenever you square it. So again, even though there is an x in my denominator, there is no x value that's going to make that become a 0. So this is another example of an all real numbers situation. Okay? So my domain is going to be all real numbers. All right, so we're okay with finding domain? Yeah? All right, assuming so from the silence. So now what we're going to get into is how to write a rational expression in lowest terms. So if you're asked to simplify something, how can we simplify it as far as we possibly can go? So our first step for writing rational expressions in lowest terms. You're going to factor both the numerator and denominator to find their GCF. Now when I say to find their GCF, we're looking for the GCF of both the numerator and the denominator. You might need to find the GCF of the numerator to actually factor it, but we're going to try to look for the greatest common factors of both the numerator and the denominator. And then step 2 will be to cancel out any common factors. So this is where it gets fun. You start factoring things, and then you start seeing things in common, and you're like, yeah, I can put a big strike through that and get rid of it. And then it's even better when you can do like a whole bunch of strikes through and get rid of a whole bunch of stuff. It's really exciting. I'm telling you, I could just factor for the rest of my life and I'd be content. All right. You ready to see it in action? Here we go. Nice and simple one, already factored for you. So in your numerator, you have 2 linear factors. Your first is x plus 5. Your next is x plus 2. In the denominator, you have x plus 2 and x minus 3. So it's already in factored form for us, so step 1's done. Sweet. Now let's go to step 2. We're going to cancel out any common factors. So what's in common in the numerator and the denominator? X plus 2. So I'm going to strike it. So what's left over? Good. X plus 5 all over x minus 3. So I wrote the rational expression in its lowest terms. Okay? If I were to put this in a function form, which is not in function form, remember from chapter 5, when it was in function form, that's when we had to talk about the domain. But I'm not in function form yet, so I don't need to include my excluded values. Okay? All right, so now let's do one where we have to actually factor it ourselves. So a squared minus a minus 6 all over a squared plus 5a plus 6. All right, so factoring the numerator, my leading coefficient is 1. 1 times negative 6 is negative 6. What are factors of negative 6 that get us to negative 1? Negative 3 and 2. My leading coefficient is 1. So my numerator factors to a minus 3, a plus 2. Just so happens to be a coincidence that my constant in my denominator is a positive 6. What are factors of 6 that get us to 5? 2 and 3. So that factors to a plus 2, a plus 3. What can we slash out? A plus 2, which leaves me with a minus 3 all over a plus 3. Okay. So far, so good? All right. Let's go to this one. Y squared minus 4. In my numerator. 2y plus 4 is in my denominator. Go ahead and factor the numerator. Good. So we got y plus 2, y minus 2. What about that bottom one? Yeah, I like that idea. GCF 2, so then I'm left with y plus 2. What can we strike out? Y plus 2. So my lowest terms are going to be y minus 2 all over 2.
Which is all real numbers.
That would be an all real numbers scenario in the simpler form. All right, how about this one? I see a lovely difference of cubes. See if you can do this one on your own. See if you remember your difference of cubes pattern. Yeah, or just nothing. And I mean, sure, if you put the 1 there, that would be okay.
Alright, just want to make sure.
I would just leave it with the numerator. So you should be left with x squared plus 3x plus 9. Your x minus 3's would go away. All right, let's do one more of this, and then we're going to step up our game even more. And then we'll do some practice problems before we do dividing. Is everybody okay? All right. PR plus QR plus PS plus QS all over PR plus QR minus PS minus QS. Now before you do anything, just pause for a second because students make this mistake all the time. We can only cancel out common factors. Is anything up here yet written as a factor? No, there's plus signs between them. So you can't just say, oh, I got a PR here, I got a PR here, take it out. Oh, I have a QR here, take it out. You can't do that. You can only cancel out factors, which means it has to be written in factored form before you can start canceling anything. So I see 4 terms. We try factoring by grouping. Can we group it by 2's? I think in this case we can. So group the first 2 together. What can we take out? Take out an R. So then I have a P plus Q left over. What can we take out of the second set? An S. And then I'm left with P plus Q. So my numerator factors to what? Good. R plus S and a P plus Q. And that's going to be all over. Do the same thing to the denominator. What can we take out of the first 2? An R. So I'm left with P plus Q. What are we going to take out of the second set? Negative S. So now I'm left with P plus Q. So that factors to R minus S times P plus Q. What cancels? The P plus the Q. So then we have R plus S all over R minus S. Okay. Now, of course, there may be some times where you don't have any common factors. And if you don't have any common factors and nothing cancels out, then it already was written in the lowest terms. Okay, so we've got this. Now this is just our foundation to be able to multiply and divide rational functions. Okay, so what we're going to do is we're going to do some multiplying of rational functions, and we're going to do some practice problems, and then we'll come back and then we'll do dividing because it's very similar. And then you'll have the remainder of class to work on your homework. All right, so let's pass through those guys. So multiplying rational expressions. So step 1, multiplying rational expressions. Factor the numerator and denominators. You want to factor it as much as you possibly can. So remember, we can only cancel out factors. So you want to get them to be all factors. Okay, so we're factoring numerator and denominators as completely as possible, just like we did with our simplifying to lowest terms. After we've done that, we want to cancel out any common factors, just like we did with our simplifying our rational expressions. Whoa, there we go, it's coming. And then our last step will be to multiply remaining factors in the numerator and remaining factors in the denominator. Okay, and then you're going to leave the denominator in factored form. All right. Are you ready? Okay, so here's our first example. So I have two rational functions being multiplied together, or rational expressions, I guess. So if we have 5p minus 5 all over p times 3p squared all over 10p minus 10. All right, so let's start with the first one. First numerator, what can I factor 5p minus 5 to? What can the GCF be? Take out a, let's just take out a 5. If that first term was a negative, then I would take out a negative, but let's just take out a 5. So 5 would leave us with p minus 1. I can't factor p any further, so that's just going to stay a p. Times 3p squared. Can I factor that? Nope, it's just a monomial, so I'm just going to leave it as 3p squared. All over, what can I factor 10p minus 10 to? GCF of 10 leaves me with p minus 1. All right, well, right away, what do you see that's going to cancel out? Yeah, I have a p minus 1, because really, when you multiply fractions, you just multiply straight across. So we can cancel out on that diagonal. So I can take out that p minus 1. What else is going to reduce? 5 and 10. The 5 is going to go to a what? 1, and the 10 will go to a 2. Good. 5 tenths is 1/2. What else? Yeah, so if I've got 2 p's in my numerator and 1 p in the denominator, they would cancel out and be left with just 1 p. So now what am I left with? What am I left with in my numerator? A 3 and a p. What am I left with in my denominator? Just a 2. Okay. Now, if that looks really confusing to you, it may be helpful. So let me just go back without the crosses. So we had 5p minus 1 all over p times 3p squared all over 10p minus 1. The commutative property will allow you to rearrange all of this here together. So what you could do is just flip-flop and put your like parts together. So I see just a single p here, so maybe I'll move that p over there. So then just make it look like 5 minus p minus 1 all over 10 and a p minus 1, and then 3p squared all over p. So it might make it a little bit easier to see these cancel out. 5/10 goes to 1/2. My p squared divided by p would just go to 1p. I don't know. So you can rearrange things to make it look a little less chaotic, but you can just start canceling everything out. All right, let's try this one. K squared plus 2k minus 15 all over k squared minus 4k plus 3. Then we're going to multiply k squared minus k all over k squared plus k minus 20. All right, so we just start factoring. Numerator, factors of negative 15 that get you to 2. Five and a negative 3, my leading coefficient is 1, so that would just go to k plus 5, k minus 3. Okay, now let's do the denominator. Factors of 3 that get you to negative 4. Negative 3, negative 1. So k minus 1, k minus 3. If it makes you feel satisfied, what do you want to cancel out right away? Let's do it. So now I feel like I did something sufficient. All right, k squared minus k. Factor that. GCF of k, so I'm left with k minus 1. Denominator, factors of negative 20, that get me to 1. 5 and negative 4, so that would go to k plus 5, k minus 4. Does anything cancel out right there? No. But what about with both of them combined? K plus 5, let's strike it. Anything else? K minus 1, let's strike it. Isn't that so satisfying? I think it is. So what's left?
K over K minus 4.
Good. K over K minus 4. And that's just like, it's great. It's beautiful. It's beautiful how that stuff works. All right, let's do one more and then we'll do some practice. P minus 4 times 3 all over 5p minus 20. It's the only thing that's going to have to factor. So we'll take out a 5. Now I'll go to p minus 4. What goes away?
P minus 4.
Good. So what am I left with?
0. 3/5.
3/5. Nice.
What's that?
Simple as that. All right, so let's go ahead and try some of these out. So grab yourself a practice space, whether that is your notes. When dividing rational expressions,
Just pronounce.
yep, you turn into multiplication by flipping the second rational expression. So that same thing holds true for when you divide fractions. Right? So if you had 1/2 divided by 1/3, that's the same as taking 1/2 times 3/1. Right? It's our basic rule of thumb when we're multiplying. It's the same, or sorry, dividing is the same as multiplying by the reciprocal. So the only thing that's going to change is if you see a division sign instead of a little dot between your rational expressions. Before you do anything, turn your division into a multiplication and take the reciprocal or flip the second rational expression. And then just proceed as we have been doing. Okay, so let's try one of those. Is everybody good? Alright, so on your practice space or in your notes, wherever you want to put it, let's try a division one. So let's do, no, we're not ready for cubes yet. How about 12x minus 20 all over 5x divided by 9x minus 15 all over 6. So before I would even proceed with anything, I would rewrite it as 12x minus 20 over 5x times 6 over 9x minus 15. It's the GCF of 12x and 20. 4, so then I'm left with 3x minus 5 all over 5x. Nothing cancels out right there, so now let's move on to the next. GCF of 9x and 15 would be 3, which leaves me with 3x minus 5. What can reduce right there in that fraction? Your 6 and 3. So my 6 can turn into a 2, my 3 can turn into a 1. What else is going to cancel out? 3x minus 5s. Why would the 4 and the 2 not cancel out? Because they're both in numerators. Good. So what's left over? My numerator has 4 times 2, so 8. And my denominator, we're just left with 5x. Okay. All right, let's do one more challenge problem. I'm going to give you some cubes in here. See if you can do it. So x to the third plus y to the third all over 2x plus 2y. This will be the last one. I'll give you your homework. Divided by x squared minus y squared all over 2x minus 2y. So you have a sum of cubes, so you have to remember the sum of cubes. If you do not have that memorized yet, you might want to work on that. X plus y times x minus. What's that noise? Can you not have it make noises? Is there a way to silence it? Yep.
All right, once you get there, you put your smart files. And all you have for homework is 10 problems.
Yup, yup.
Oh, just kidding.